Here are another couple hydroxylation of alkene reactions. This time, instead of adding to opposite sides, what these reactions will do is add to the same side. So before, in reactions such as acid catalyzed openings of epoxide rings and stuff like that, they added to opposite sides. The point of these ones is to get something that adds on the same side, like so. Well, we got two different examples here, osmium and permanganate. They're very similar looking, and it's pretty much the same reaction, so let's just go over it really quickly. But don't really worry about the in-between steps with transition metals. I just don't really want to spend time going over. If you want to learn about transition metals, just pick up an inorganic chemistry book. But here, there's one of these bonds is going to break, and it will go to the electrons will go to osmium, and then the other oxygen will bond to it, essentially creating this. We've got these bonds over here, and the other electrons have gone to osmium. Osmium has a lot of orbitals. That's why it's not deficient something. You got to remember it's not. You got to remember about the orbitals. And transition metals, they're not dealing with S and P orbitals. They've got D orbitals. So you got to remember that, and they can have multiple oxidation states. So that's what I mean. Just don't worry about it so much. This is organic chemistry. This is not going to really. I could talk about it, but I don't really want to spend the time. It's not on topic. So both of them have something similar going on. We'll just go over both of them at the same time, pretty much. So, crap. I did something wrong. Hold on. Forgot the oxygen. But it should look like this, right? And then in this step we use hydrogen peroxide or some amine oxide, R3s. These are carbons, nitrogen, oxygen. And this will add water across the bond. And then for the osmium, it's regenerated. So we don't really need a lot of this stuff because it will just, whenever we hydrolyze this stuff, it's regenerated. The manganese, or not manganese, the permanganate one, we hydrolyze the bond as well, but it turns into a solid. So this can be good or bad for us depending on what the reaction is. One of the interesting notes that is in this book is just the cost as well. I haven't used osmium, but I've used permanganate before. I used it in a titration a while ago. It's got this really deep pink color. But it's interesting to take the cost into account because this has about a 65% yield and this has a 50% yield, more or less. And I'm also bringing this up as well because depending on what a lot of times we've got a lot of ways of doing the same thing often in organic chemistry. So which one is best? Sometimes we'll pick one because we want to avoid side reactions. Other times we'll pick it because it's more convenient to use. But sometimes it's a cost perspective, or it says supposedly this is not easy to deal with, it's very volatile, so it's more annoying to deal with. But sometimes it's worth the nuisance because we don't really need a lot of it since it regenerates itself, and also it has higher yields. There's nothing more annoying than in a chemistry reaction where sometimes things just don't go according to plan for whatever reason. You calculate theoretically, in a multi-step synthesis could be 10 steps, and then at the end if we plan for permanganate and we wanted X amount and it's just not going to get us that amount, then we might need to use osmium just because we don't feel like doing all the stuff again. But also another good way of looking at it too is just to think we're getting 15% more, and if it's at the final step of a synthesis, we can just look at the cost of what 15% of all the previous products are, or the previous reagents are, and compare that to the cost of the osmium. And if the osmium is more, then we'll use permanganate. If it's less, then we'll just go ahead and use it. But if it's the first step of a synthesis, then more often than not it's going to make sense to use permanganate because it's just cheaper and it's the first step. But of course, we'll always have to factor in all of the costs and have a look at what is best. But besides that, it's a pretty straightforward reaction, at least from looking at it at this organic chemistry perspective. I don't really want to make this about inorganic chemistry, but if you're interested, just pick up one of those inorganic chemistry books. You can find them pretty cheap online for like $20.